Hello friends, I am starting new chapter triangles. Triangles of class 10th. Under the triangle, there are two things. One is congruency and second one is similarity. So in class 9, just let me remind you of class 9th, you have understood about congruency. Do you know what is congruency of triangles? Or what is congruency in a broad spectrum? Congruency, that means two or more figures, they are equal shape wise as well as size wise. It's called congruent. So we have studied about the triangles, congruent triangles. That means the two triangles, they are exact same. That means sidewise, size-wise as well as shape-wise. Okay. For example, suppose two triangles on my hand. If I put one triangle on another, that means one triangle will hide completely to the another triangle. What does it mean? All corresponding angles and all corresponding sides are exact same, equal. So that means two or more figures, they are equal shape wise as well as size wise. It's called congruency, congruent. But here in class 10, we'll have to discuss about similarity of two triangles or similarity of two figures. What is similarity? There's a difference between similarity and congruency. In the congruency, the figures are shape wise and size wise are equal, but in similarity, the figures are equal shape wise only, not size wise. Only shape wise they are equal. Shape wise, what does it mean? For example, if I'll take one circle, it is a circle, and this is the second circle. So both the circles, they are equal shape wise, not size wise. Its radius is less than the radius of the bigger circle. So radius are different. This is R1 suppose, and that is R2. So that means their radii are different, but we can say that shape wise they are same. Same as if I take one triangle ABC and second triangle PQR. Since both the triangles are equilateral, what does it mean? Their each interior angle is equal to 60 degree each. So what does it mean? Shape wise they are equal, both are equilateral, but side wise need not same. Suppose the side is here 5 centimeter, 5 centimeter, 5 centimeter, it is 7 centimeter, 7 centimeter, 7 centimeter. These are 7, 7 and 7. So both the triangles are considered as both the triangles are similar. Okay, because they are corresponding angles are equal, but corresponding sides are not equal, but the corresponding sides are in the same ratio. Same ratio, what does it mean? If the corresponding side AB and PQ, so AB upon PQ is equal to BC upon QR is equal to AC upon PR. Second example. Third example is there is a square, second square, third square. All the squares are similar. Reason? Because the interior angle of each square is 90 degree. But it is not necessary their sides are equal. So friends, these are the examples of similarity. Okay. And when we start the chapter triangles in class 10th, here one most important theorem is that is known as Thales theorem or basic proportionality theorem or fundamental theorem. So this is the most important theorem. I am going to prove this theorem which is based on this triangle, and there's a very specific relation in the triangle when we draw a line parallel. So one theorem, this I am explaining because this is very important as far as the triangle chapter is concerned. And when we prove any theorem, first of all, there are 3 or 4 parts in the theorem. Number 1, we'll have to go through the statement of it because statement is a thing from the theorem. We can draw everything from it. Statement. So number 1, statement. First I am writing here Thales theorem, or the second name is basic proportionality theorem. Or the third thing is fundamental theorem, basic proportionality theorem, BPT. Commonly it is known as BPT, basic proportionality theorem. Okay, so let us start it. First of all, statement of the theorem, which says in a triangle a line is drawn parallel to one side of triangle to intersect other two sides in two distinct points, divides two sides in the same ratio. This is the statement. What does it mean? See, I'm writing here, in a triangle a line is drawn parallel to one side, intersect other two sides in two distinct points, divides the sides, divides two sides in the same ratio, divides two sides in the same ratio. Distinct means two different points. Now let us understand the meaning of this statement. In a triangle, a line is drawn parallel to one side of the triangle. So when we prove theorem, this is the basic rule of proving any theorem. First of all, statement. After that, there's a diagram. And diagram we have to sketch on the basis of the statement. Statement says, in a triangle, this can be any type of triangle, equilateral, isosceles, or scalene. In a triangle, a line is drawn parallel to one side. That means just I am making a triangle. That is a triangle. I can give the name there, suppose A, B, and C. In a triangle, a line is drawn parallel to one side of triangle. Suppose I have drawn this line. Give the name DE. Line is drawn parallel to one side of triangle to intersect other two sides at two distinct points. One other side AB, other side AC is dividing at 2 points D and E. These are the distinct points. Divides two sides in the same ratio. That means we are proving that this line is dividing AD upon DB is equal to AE upon EC. This is the meaning of this statement. I hope you have understood. So the diagram. After diagram, 4 things. Number 1, given. After that, 2, proof. Third one, construction if required. And 4th is proof. First, given. In the given, which term is given? I think in a triangle ABC, one line DE is parallel to BC. So simply I'll write here, in triangle ABC, DE is parallel to BC. In fact, this DE, the points which I have taken, you can also take the points anything by your choice. In triangle ABC, DE is parallel to BC. It is given. To prove. What we are going to prove? That divides two sides in the same ratio. That means AD upon DB is equal to AE upon EC. AD upon DB is equal to AE upon EC. This we want to prove. After that, construction, whether it is required or not. So for this theorem, I will tell you that yes, construction is required, because this AD, DB, AE and EC, we are taking the base of a triangle and using the formula area of triangle half into base into height. So since the heights are not present here, so we have to draw heights. That means the construction is required. Construction. Construction. In construction, join B to E, join B to E, join C to D, join B to E, join C to D, and as I told you, perpendicular is required. So two perpendiculars are required. One is this and second perpendicular is this. I will give the name here. Suppose it is P and that is Q. And draw DP perpendicular on AC, EQ perpendicular on AB. EQ perpendicular on AB. DP perpendicular on AC and EQ perpendicular on AB. Given to proof and construction. After that, a most important part of the theorem, that is proof. So friends, the proof will be done like that. First, AD upon DB. AD upon DB. I am going to select two triangles in such a way that their bases are AD and DB respectively. Bases are AD and DB respectively. So you can see the triangle. One is triangle ADE and second is triangle I am selecting DBE. What is the reason? So that their bases are AD and DB. Both are coming in the form of base. Okay. So I am taking now area of triangle ADE upon area of triangle DBE. Area of triangle ABE. You know that the formula of area of triangle half into base into height. Half. What is base? In triangle ADE, the base is AD. What is height? In this triangle ADE, height is EQ. Because height is always perpendicular on the base. This is one thing. Height is always perpendicular on the base. Upon in triangle DBE. DBE. Because it is compulsory, we have to take base as DB. Only then we can preserve AD upon DB. So base is DB. Half base DB and perpendicular. What is the perpendicular in it? Triangle is DBE. You can see that in this triangle DBE, this is obtuse angle. And friends, when in a triangle, it is an obtuse angle triangle, then what happened? Its height will be outside of the triangle. Suppose this is a triangle. In this triangle, if that is the base and I want to draw the height from here, so height is the definition of the height which is perpendicular on the base. So when we draw the height from here, so definitely we have to extend this BD up to Q. Okay. What does it mean? Half base is DB and height is EQ. I hope you have understood. I'll give you, this is with the help of this diagram, I'll tell you. For example, suppose this is a triangle. Obtuse angle triangle. A, or I am exactly taking this B, this is D, and here is a E. And this is a one compulsory thing that we have to take for finding the area of this triangle. We want to take BD as a base. So if the BD is a base, then what would be the height? Height is through point E, we have to draw one perpendicular. So when I draw the perpendicular, I have to extend this BD up to here, and this angle is 90 degree. It is point Q. So what does it mean? Half base DB base and height is EQ. Height is EQ. 1 upon 2 and 1 upon 2 cancel, It is coming area of triangle ABE upon area of triangle DBE is equal to AD upon DB, because EQ and EQ cancel. It is equation number 1. So I have got it, AD upon DB is equal to this part. Now, second term, AE, since we are going to prove that AE upon EC is equal to this one. AE upon EC. Again, you see the triangle, where's the AE? And I am selecting a triangle in which base is AE. So triangle is AED1 and second base is EC. Triangle is ECD. So now area of triangle AED upon area of triangle ECD. Area of triangle AED, again using the same formula, half into base into height, half base. Now this time we have to take base as AE. What is height? In this triangle, since base is AE, that means height is DP. Height is DP. Upon half ECD. Half base EC. And height is, again the same concept is using here. For drawing the arc through point D, when we have to draw the perpendicular, CE will be extended. This is, so what does it mean? The height is DP. Again 1 upon 2 DP cancel. Area of triangle AED upon area of triangle ECD is equal to AE upon EC. Gives equation number 2. Now look at carefully equation number 1 and 2. On the right hand side, AD upon DB and AE upon EC. Since we are going to prove that AD upon DB is equal to AE upon EC, so for proving the right hand side equal, if we will prove that their left hand side terms will be equal, then automatically it would be proved. So now let us see the left hand side term of equation number 1 and 2. Left hand side, numerator and denominator. Numerator, area of triangle ABE, and here is the numerator, area of triangle AED. Area of triangle ADE and area of triangle AED. Both the triangles are same, they are equal in area. So I think the problem has been sorted out. Numerator terms same. Now let us see the denominator. Denominator, area of triangle DBE. Area of triangle DBE. Friends, this DBE. And area of triangle ECD. ECD. What does it mean? In these two triangles, one DE is the common base of this triangle, as well as DE is the common base of triangle DEC. Okay, and I think you have remembered in class 9 we have studied a theorem that two or more triangles, they are equal in areas if they are on the same base and between same parallels. And here the same situation, two or more triangles are equal in areas. See, one triangle DEB and second triangle is DEC. There are two triangles, they are equal in areas if they are on the same base is DE, and between same parallels. Same parallels are DE and BC. So what does it mean? Here I have to write here, since area of triangle DBE is equal to area of triangle, since area of triangle DBE is equal to area of triangle ECD, because as we know that two triangles are equal in areas if they are on the same base and between same parallels. They are on the same base and between same parallels. So here you see that the DE is same base for triangle DBE and triangle ECD, and DE is parallel to BC. DE is parallel to BC. So what does it mean? Y1 and 2, Y1 and 2. Y1 and 2, since their left hand side numerator is same, left hand side denominator is same, what does it mean? Their left hand side part of 1 is equal to the left hand side part of 2. So Y1 and 2, their right hand side must be equal. AD upon DB is equal to AE upon EC. AD upon DB is equal to AE upon EC. So this is the proof of Thales theorem, or we can say the basic proportionality theorem or the fundamental theorem of geometry. But not only this proof, two more proofs are required here. Number one, already we have proved that AD upon DB is equal to AE upon EC. In this, whatever the proof we got it, in this proof, here I am using one more concept. If AD upon DB is equal to AE upon EC, adding 1 on both sides, because this is an equation. On the equation you can add 1 both sides or subtract 1 from both sides, there is no problem. Adding 1 on both sides, then you will see what the result is coming. DB remains as it is. It is AD plus DB, because 1 upon 1 LCM is DB. AD plus DB is equal to EC AE plus EC. And friends, AD plus DB, which makes AB. So may I write here AB upon DB is equal to AE plus EC, which makes AC. AC upon EC. I can reciprocate this also. AB upon DB. AB upon DB. Now see the diagram. AB upon DB is equal to AC upon EC. So that is the second proof. Third one, if from the whole AB we subtract BD, then the remaining is AD. So that means the third proof is AB upon AD is equal to AC upon AE. So that means not only a single this proof is there, we have to remember two more proof. If in any triangle if one line is parallel to another, suppose in a triangle a line is drawn parallel to one side of triangle, then AD upon DB is equal to AE upon EC. Important one proof, number one. Second, AD upon AB is equal to AE upon AC. Number two. Third, DB upon AB is equal to EC upon AC. Number three. So these are the proofs. Through the Thales theorem we can get it. Okay. So I hope boys you have understood this theorem. Friends, I have taken one application of this Thales theorem. This is a triangle ABC. In this triangle, it is given that DE is parallel to BC. What is given? Given that DE is parallel to BC. And in the proof of Thales theorem, I told you one thing very clearly, that if any triangle is there, if one line is parallel to another line, then this line will divide other two sides in the same ratio. It is clearly mentioned DE is parallel to BC. That means by BPT, by basic proportionality theorem. What we can write here? We can write here AD upon DB is equal to AE upon EC. Because I told you there are three results, but this result is required since we are finding the value of this AD. All sides are given. DB is equal to 7.2, AE 1.8 and EC is equal to 5.4. We are finding the value of AD. Okay. So the question is, in this diagram, find AD. Given that DE is parallel to BC, in this triangle line is parallel, AD upon DB is equal to AE upon EC. Okay. Now we'll substitute the value. AD, nothing is there, remains AD as it is, upon DB 7.2 is equal to AE 1.8 upon EC 5.4. So out of these four, you can see that the one AD is unknown. We are finding the value of AD. Cross multiply. 5.4 multiplied by AD is equal to 7.2 multiplied by 1.8. Therefore, AD is equal to 7.2 multiplied by 1.8 upon 5.4. First, we'll have to remove all the decimal. 72 into 18 upon 54. 18 3 ja 54. 3 2 ja 6, 3 4 ja 12. So this is coming 24. But remember this, there are two decimal is a single decimal. That means one more 10 will be coming here. Why it is? Because after decimal one number, after decimal one number, so there are two zeros coming downside, one zero upside. That means one 10 is left here. So 24 upon 10, it is coming 2.4 centimeter. That means the value of AD is equal to 2.4 centimeter. Okay. So friends, this is the application of this theorem. Okay. In my next video, I'll tell you and I'll prove you that how to prove that the converse of BPT.